All right, team, the ideal gas law is related to the combined gas law. And we can almost think about it like a different application of the combined gas law, or even the combined gas law, a different application of the ideal gas law. And we'll get into that momentarily. But first of all, let's talk about what the ideal gas law is. The ideal gas law is P times V is equal to N times R times T. Or sometimes we think about it as PV over NT equals R, where P is pressure, V is volume, N is moles, T is temperature Kelvin, and R is the gas constant. In our class, I'll normally be using this form of the gas law, but sometimes people prefer to use the other rendition of it, modified by algebra. I don't know. It's just both work and are essentially the same equation, just rearranged. One solving for R and one solving for PV or nRT. So recap. These are our units, PVU tables, pressure variable unit. So make sure you pay attention to this, and you need to realize what properties are described by which unit. And temperature must be in Kelvin. All right, to do that, we take the temperature Celsius and add 273. So here's the ideal gas law right down here. And this is the combined gas law up here. And this is why we can use the combined gas law, because the ratio of the products of pressure and volume to the product of moles and temperature is equal to a constant. So that's why we can use this combined gas law. And our ideal gas law, PV is equal to nRT. And I've shown you guys the algebra right over here. So when to use which law? So the ideal gas law is going to be used when you're given three of the variables, pressure, volume, moles, or temperature, three of those four, and you're asked to calculate the fourth one. The combined gas law is used to predict how a property will change if you change some of the other factors. So if you're given a pressure volume and you're changing one of the pressures, and you ask to calculate to predict the effect on the volume. So that's what the combined gas law is doing. These are your R values. I want you guys to write all these down with the units, and this is going to be important. We're going to be getting into this later today. Like I said before, the value for R depends on the units which you're referring to. So for instance, if you're referring to liters, kilopascals, moles, and temperature Kelvin, you're going to refer to the 8.31 value for R up there. If you're referring to liters, atmospheres, moles, and Kelvin, you're going to be referring to the 0.0821 value for R. And lastly, if you are referring to the liters, millimeters of mercury, moles, and Kelvin units, you're going to be referring to 62.4 as the value for R. Now, you could convert R to anything. If you had R in pascals or milliliters or centimeters cubed or grams, you can convert R, or you can convert your units into the units of R. So if you had grams of a gas, you would convert to moles of a gas. If you had milliliters of a gas, you would convert to liters of a gas, etc. Or you can convert the value for R as well. So let's go over one example of a problem. We'll do the first one. Let's go through this together, guys. We'll go through this nice and slow. Why don't you guys see if you can identify your what's given first, and then we'll move on from there. So you're given three variables. See if you guys can identify which one's which. So first off, let's talk about that 11.2 liters. That is the property of volume. The 50 kilopascals, kPa, is a unit of pressure. And my 100.0 K is Kelvin, which is my temperature. So I'm going to put all these values in here under the variable that we've defined them as. And I want to know how many moles. Okay. So this is the part where you have to look at the different values for R. I need to find one with KPA, liters, Kelvin, and moles. So that value is 8.31. And I have color coded it so you guys can see that. So here's our ideal gas law. P times V equals N times R times T, more commonly known as PV equals nRT. And I substitute my values in here. And I calculate my values. I can take the products of those numbers. And I get an equation, 560 is equal to N times 831. I can solve for that, and I should have got 0.674 moles. All right, so let's do a couple more. We'll do another one right now, and then we'll move on. Okay.